Okay, this is number 25 on homework 32. And it says the decay equation for radon 222 gas is known to be y equals y sub 0 e to the negative 0.18 t. With t in days, about how long will it take for the amount of radon in a sealed sample of air to decay to 90% of its original value? So they give you your formula over here, and this again is based upon exponential change here. Exponential growth, I should say. In this case, decay, because it's going to be negative. And we want to have 90% of the amount. Well, this is my original amount, and this is the amount I have at any given time, so I want that ratio of the amount I have to the original amount to be 90%. So that's just 0.9 as a decimal. So that's going to take care of both these variables, and all of a sudden we have this equation equals e to the negative 0.18 t. All we have to do is solve for t, so we can take the natural log of both sides. That's the natural log of e to the negative 0.18 t. And then I can bring that down in front, that exponent. So that equals negative 0.18 t times the natural log of e, which is just 1. So that goes away, and then I just divide both sides by negative 0.18. So t equals the natural log of 0.9 divided by negative 0.18. So my approximate value for t, you put that in your calculator, you end up with 0.585 days, approximately. So that's not bad, is it? Okay, so that wasn't too hard. Then number 27, this was off the graph, so you had to get your information off the graph, and they gave you a couple points. And again, they also gave you the equation. Okay? So number 27, find the exponential function. Y equals y sub 0 e to the kt, whose graph passes through the 2 points. Well, we're lucky they gave us one was a 0. So that makes it nice because that's my initial value. Because when t is 0, y is 2. That means y sub 0 is 2. And then I've got this other point. When t is 2, y is 5, so I can find my k that way. So I'm going to rewrite this first one. Y equals, instead of y sub 0, I can put 2 e to the kt. So all I have to do is find out what k is. And they tell me that y is 5 when t is 2. So I just take the natural log of both sides. Well, before I do that, I better get rid of this 2. Otherwise, it'd be a little bit messy, so I'll divide both sides by 2 first. So 5 divided by 2 equals e to the 2k. I'll put the 2 in front. And this is the same thing as what? 2.5, so I'll take the natural log of both sides. So the natural log of 2.5 equals the natural log of e to the 2k. Watch out for my k's there. And then I'll put this in front, so I have the natural log of 2.5 equals 2k, right, times e. I'm sorry, 2k times the natural log of e. And that's just 1. So I divide both sides by 2. So I get k equals the natural log of 2.5. Okay, and all that's divided by 2. Okay, and then you could write that in your equation like this if you want. Y equals 2 e to the, and sometimes they write it like this so they don't have a big fraction, 1/2 the natural log of 2.5 times t. But if we approximate that with our calculator, we'll get y equals 2 times e to the, and then that's approximately 0.4581 t. So either one of these would be okay. All right, so that wasn't too bad. Get this down so you can see the whole thing. And I'll try to make a snapshot of these so That might make it a little bit easier to zoom in, okay?